All right, so our next section is about angles and arcs in a circle. And so this section is pretty easy. I think you guys will like it. Here we go. So first of all, a central angle is an angle in a circle with its vertex at the center. So a few examples of a central angle here could be this angle here, angle ARB. That could be a central angle. Another one could be angle CRB. Now remember, order doesn't matter, so CRB would be the same as BRC, and ARB would be the same as BRA. Another one could be this straight angle here, which could either be called ARC or CRA. Those are all central angles. One thing about a central angle is it's always going to be 180 degrees or less. And so I say that because you may be asked to say, like, identify the measure of. Okay, sorry about that. So if I asked you to find ARB, that's always going to be this one that's less than 180. It's never going to be like this whole angle here. Okay, so one other thing about central angles is that all of them, the measures of all the central angles in a circle, add to 360. Okay, so let's do some practice with some central angles. One thing that I want to point out is that I think is really helpful is when you're given a picture like this and asked to find like a bunch of angles or even arcs when we get to that point, I like to fill in the picture first, like find everything that I can find, and then that makes it really easy to identify the ones that they're asking for. So what I mean by that is, first of all, it says that RU is a diameter. Remember, diameter means that it goes through the center. Anytime you have a diameter, that just means that it's 180 on both sides. Most of the time, they'll tell you when you have a diameter. Every now and then, you might get one where it doesn't quite say, but you can usually tell if it's a diameter. It's like straight, it goes right through the center. Okay, so now we're going to use that to find some missing parts. See how this one's 90, so that would make this one 45. Then think about like these three are going to add to 180. So that would make this one here 75, because if you add 45 and 60, you get 105, subtract from 180. Over here, we could just subtract 45 from 180 to get 135. So I like to fill in the circle first, and then that makes it super easy to find the ones that we're looking for. So if we're looking for SCT here. So SCT, we already found is 75 degrees. Number 2, SCU. SCU is these two together, which is going to be 75 plus 60, which is 135. Number 3, let me erase some of this. Oops. Number 3 is SCQ. I'll just use a different color. SCQ is here, so that one would be 90. And then number 4 is QCT. QCT. So remember, that's this way. It's not the opposite way. So for that one, that would just be 90 plus 75, because this is 90 and this is 75. So that'd be 165. Okay, so that's how you find central angle measures. Now, central angle measures are directly related to arc measures. Okay, so next is an arc. An arc, the definition, is an unbroken part of a circle. So one example of an arc would be like right here, arc AB. Arcs are typically named with their end points. On the next part, we'll talk about some more specific arcs and how we name them. Arc CB would be like that one. I could name many more arcs on this circle. There is a symbol for an arc. It's kind of like the symbol for a segment. It's a little miniature arc above the letters. So if I wanted to do arc AB with the symbol, it would be capital A, capital B, with a little curve on top. If I wanted to do arc CB, it would be capital C, capital B with a little arc on top. Now these could be reversed too, just like a segment. I could do BA, arc BA, or arc BC. The order doesn't matter. Okay, so there are some types of arcs. We can classify them by their measure. So there are 3 types of arcs. The first one is a major arc. A major arc is one that is more than 180 degrees. Another thing about a major arc is that it's named with 3 letters. It always has to be 3 letters. So the 3 letters that you use are you use the 2 end points, and then you choose any point in between. Okay, so if you look at this picture, here would be a major arc, arc HJI. So notice I used the 2 end points and I used J, which is in between them. If I added another point in between them, that would open the door to more options of naming it. Like I could say HXI now. You wouldn't ever want to do like HXJI, like only 3 letters. So the beginning, something in between, and then the end. Which this I could also do, like I could start with I and do like IJH or IXH. That would work too. Okay, so a minor arc is an arc that's less than 180 degrees. Minor arcs are typically named with 2 letters if you only need 2 letters, but every now and then you will see minor arcs named with 3 letters. And again, you just use like the endpoints. So like this right here would be a minor arc because it's less than 180. So we would say that it's either HI or IH. Remember, capital letters. So that's a minor arc. The last type of arc is a semicircle. So a semicircle is an arc whose measure is exactly 180 degrees. So major is more than 180, minor is less than 180. A semicircle is exactly 180. It's half of a circle. I'm sure you've heard that term semicircle before. Semicircles can be named with 2 or 3 letters. Okay, so now the measures of these arcs, you use the central angle. So see, it says the measure of a minor arc is just whatever the central angle is that creates that arc. So if you look back at this example up here, this arc HI would be whatever measure angle 1 is. Angle 1 is the central angle for that arc. Then it says in that box that for a major arc rather, you take 360, which would be all the way around, and you subtract the central angle. So this angle 1 would still be considered the central angle measure for this arc, and here's why. So like every central angle will have 2 arcs that are created. There's the minor arc that's in between the 2 letters like that, and then there's the major arc, which goes the opposite way. So you could find the measure of a major arc by just doing 360 minus that angle. You could also just like add together all the smaller angles that make, or all the smaller arcs that make that big angle, either way. And then a semicircle is exactly 180. So to find these measures, we do it kind of the same way that we did on the other problem. I like to fill in everything in the picture and then go and like fill in the answers. So for example, it says BOA is 44. So that means this one would be 44 because they're vertical, and these are diameters. So they'd be 180 on each side. So if I do 180 minus 144, I get 136. These are both 136. Okay, so these directions say to find the measure of each arc and classify as major, minor, or semicircle. So the first one, BA, right here, would just correspond to this central angle, which would be 44 degrees. And since it's less than 180, it's a minor arc. Okay, the next one, number 6, is BC. So BC is here, which would correspond to that central angle. So that's 136, which is also minor because it's less than 180. Number 7 is CD, which would correspond to right here. So that would also be 44 degrees. Also minor. Okay, number 8 is ACB. So you want to go from A to C and then all the way to B. Whoops. Okay. So A to C to B. So for that one, here's the central angle, which is 44. So we're going to do 360 minus 44, which gives us 316. Since this is bigger than 180, it's a major arc. Okay, and then the last two, we have BCD. Okay, BCD would be BCD. So notice that is a semicircle, which is 180 degrees. Okay, and then the last one, AD. AD is here, which corresponds to this one, so 136. And it's minor. Okay, so that's how you find arc measure. The last part is arc length. Arc length is the linear measure of an arc. So like how long the arc is in like inches, centimeters, whatever units they give you. So arc measure is how many degrees, like the opening of it. Arc length is how long it is. And so there's a special formula for that. Here's the formula. So to find arc length, you take the measure of the arc in degrees, and it's over 360. And then you multiply by the circumference. Remember, for the circumference, it's either 2 times pi times the radius, or it's diameter times pi. I usually use diameter times pi, but it really doesn't matter which one you use. Okay, so let's take a look at this first example. It says in circle P, PR is 9, which that's a radius. And then it says angle QPR is 120. So if this central angle is 120, then QR is 120. So it's asking to find the length of QR. So the formula is the measure of the arc, which is 120, over 360. That fraction is basically going to tell you like what percentage of the circle that arc takes up. And then you multiply that by the circumference, because think about the circumference is the distance all the way around the circle. So 120 is actually 1/3 of 360, right? So basically this arc length is going to be 1/3 of the circumference. So that's why this formula works. Okay, so if PR is 9, that's the radius. So you would do 2 times pi times 9. I would say like when I do it, I typically would just put 18 pi. I like just double the radius, but you'll get the same thing. So when you do this in the calculator, you want to do the fraction first. So you're going to take your calculator and you're going to do 120 divided by 360, which you should get 0.3 repeating because it's 1/3. Keep that decimal in your calculator. Don't put like 0.3 and then use that. You want to keep that decimal in your calculator and just do times 18 pi. So you should get approximately 18.85. Did we give units here? No, you always want to label units. I didn't give you one here, so just call it units. Okay, so that's our first example of arc length. Let's do a few more. So again, I like to fill in the whole picture. with all the angles. So if this one's 70, so is this one because they're vertical. This is a diameter, and so is this. So I could fill in that this one is 110 because these two are a linear pair. Then these three are going to add to 180, so that's going to be 60. So we're going to use that to find all these arc lengths. So letter A says that RT, find the length of RT rather. So RT is here. Oops. RT is here, which is 50 degrees. So we have 50 over 360. And then we want to multiply that by the circumference. So for each of these problems, they give you a different piece, like a different segment. Like on this one, they give us MT is 7. So you want to look at the picture. MT is a diameter. So that means the diameter is 7. So we're going to do times 7 pi. And then do that in your calculator. You end up getting 3.05 yards. So again, you're going to do 50 divided by 360 times 7 pi. And that would give you 3.05. Letter B, MST. So MST, that's a semicircle, which is 180 over 360. And then times the circumference. Now, I'm not just going to go straight to saying that it's 2 pi because we don't know if MP is a diameter or a radius. So you want to look at the picture. Notice that in this particular one, they gave us a radius is 2. So you can double that if you want and say the diameter is 4 and do times 4 pi. Or you could do 2 times pi times 2. It doesn't matter. I typically will always double it and just put the diameter in. So this one should be 6.28 and it's inches. Okay, at this point, if you want to pause the video and see if you can do C and D on your own, these are the last 2 examples we're going to do, and then you can come back, press play, and check. C is NR. So NR is here, which is 60, so that's going to be 60 over 360. And then we need to look to see PR, is that a radius or diameter? It's a radius, so that means the diameter is 26. So you're going to do times 26 pi. And that ends up being 13.61 feet. And then last one is MRS. MRS is this whole thing. This is a major arc. So we're going to take that central angle, 110, and subtract that from 360. So let's do that down here. So this is going to be 360 minus 110 is 250. So this is going to be 250 over 360. And now we need to look back at the picture and see, is NS a diameter or is NS a radius? NS is a diameter, so we don't have to double it or anything. So when we come back down here, we can just do times 10 pi because NS is a diameter. And that one ends up being 21.82 centimeters. Okay, so that's arc length. Make sure you label units. Make sure you follow the formula. If you need help putting it in your calculator, just let me know. All right, so that's it for this lesson. Please let me know if you have any questions.